My name's Daniel. I am a machine learning scientist at a company called ChainML, and I'll give a bit of an overview about us as a company, and then I'll talk about the open source project called Council. So we're a startup, and what we're working on is to offer solutions to be able to integrate generative AI applications into software in the form of agents. And specifically, we like to think of it as collaborating agents, which I'll get into a bit later. And I'm sure some of you are familiar with agents in other contexts. Here, it's really large language modeled powered agent that sort of encapsulates an entire software system from a user prompt to the final response. And so what we work on is ideating, educating our clients, as well as helping them adopt and implement and deploy their AI products. Now, what we very recently released in the open source is our platform for developing these generative AI applications using agents. And before I get into some of the details of the framework, I wanted to give an overview of some of the spirit in which we approached creating this framework. And that is to enable being able to create sophisticated agents, but at the same time also strive to have more predictability and more advanced control for these systems too. And some of the concepts that we introduce here for that purpose are agents. They have control flow and evaluation, native every time you create an agent. So control flow meaning if you have an agent system and a user message comes in, how do you route that message to the appropriate part of your software? So whether that could be an agent that has multiple skills, and you could probably imagine what a skill can be any type of thing that the agent can execute. I'll get into more detail on what that technically means, but when a user message comes in, how do you route that? How do you figure out the intent of the user, and how do you route that into the correct place in your system? And then as well, every agent also necessarily has some type of evaluation, and that could be very simple, like filtering whether something was successfully executed, but it can also be more complicated in any way that you want to evaluate your response. Is it concise? Is it relevant to the user answers, to the user question? And do you need to continue iterating on that response? Another thing that we care about are constraints, like, for example, budget constraints. So how much time do you want to give your agent to run, so it doesn't just continue sort of going in a loop past your own time budget? As well as we plan on and are introducing different other types of constraints. So how many API calls can you make in one single iteration? Also, we're building it to support multi-threading and parallel execution. So if you have an agent that has multiple skills, we offer ways to run those skills in parallel. So we also really focus on the parallelization aspect. And finally, it's also about extending the existing tooling within the ecosystem. So an agent, in theory, should be able to be powered by different types of language models. It really depends on the use case, as well as being able to integrate with everything else that's in the open source. So, for example, Llama Index, if you want to do some type of document retrieval, or building a vector index, or really anything else. So in terms of the key frameworks that we have, if you sort of see the light blue, large box with a lot of things in it, that really is an agent. And you have a user prompt coming into the agent. And so firstly, there goes the controller, and that's where that control flow comes in. The controller has access to, you'll see these like 3 rectangular boxes that are chains. And a chain is essentially a set of skills that can be executed in some type of sequence. And the skill, again, very arbitrary. It can be really anything. It could be searching for something. It could be any type of function, another LLM call, document retrieval, coding, really anything. But you have these skills in sequence, and you have, they're sort of encapsulated within a chain, and a controller selects which of the chains to execute. Could be one, could be more, depending on the user intent. And finally, once those get executed, that's when they go through the evaluator, and then the evaluator passes its results back to the controller. And the controller sort of selects the final response. The other important thing to note here is the concept of state management. So agents have access to states such as the conversational history, the results from all previous chains, the results from the evaluator for previous iterations of chains, which makes it easier to develop. So just to, again, kind of touch on that a bit more. So the agent is really the entirety of the LLM-powered application. So all the logic that takes in a user prompt initially and then returns a final response. So all those pieces together are an agent. And when you're defining an agent in code, those main pieces are the controller, as you saw, as well as the chains and the evaluator. And chains right now, they're a directed graph of skills. And as mentioned, like a skill can really be any type of service. So it can receive any type of input, whether it be natural language or not, and it can return any type of output. So a skill could literally be another OpenAI or another type of LLM call, an open source call, or it could just be just a very traditional type of function doing some type of data manipulation or any other type of algorithm.
Can I ask a question about
Sure.
the controller itself?
Yep.
Is it I assume there will be agents that are identical, right? Is it possible to have identical agents and the controller doing also resource allocation kind of roles as well?
So
just assigning skill, just matching skill sets to agents, a task to agent.
Yeah, so a controller can allocate work to other agents. If I understand your question correctly, a controller could allocate the task to another agent in the context of building a system that has multiple agents, which I actually will touch on very soon as well.
But how about the agents are identical? Let's say more like like threading the agents, like more like a resource allocation or resource management. Does it do that too?
Can I jump in? I think I understand what you're saying, Allison. The way Daniel is presenting currently, you can only do a chain. So no agents are acting in parallel to each other. They only act sequentially. Maybe there is a plan to add parallel agents later, but it's not about parallel processing. I think the question is, can agents do work in parallel to gain efficiency? And I think the answer is that currently no, but later maybe.
Yeah, I think if you want to have a system that has two agents separately, then sure. But if you kind of think about an agent that is, or rather, if you think about one agent allocating work to another agent, or you can just think about it being a chain. So a chain can be just a set of skills, or a chain can be another agent. It's the middle block, which is an agent chain, can be another agent in and of itself. Now, right now, like the chains themselves at this moment are executed sequentially. So if the first agent decides that you want to execute two chains, then at the moment they're going to be done sequentially. Within the chains, there's some parallel execution that we already have for the skills, but we haven't moved the chains to be run in parallel yet. And by extension, if you have and so therefore, like if you have the main agent running, let's say the first set of skills, and at the same time it's calling the second agent, then those are going to be happening sequentially.
Okay, I see. All right.
Yeah.
Ali El-Sharif, you have a question?
Yeah. So I guess what I'm curious about, does that mean that this framework maybe addresses the problem of hallucination, where if a question being asked outside the skill sets that are supported, the response is going to be, I don't know, versus just making up an answer.
Yeah, I think the idea is that through some of the mechanisms that we have, we can hope to address hallucination, and that can happen in different places. One of the more natural places that can happen is the evaluator. So once you're done executing a chain of skills, if you expect, or if you really want to your model, for example, let's say you have skills that are focused on document retrieval, and you know that in advance, your evaluator will know that, and you want to make sure that, or try to make sure that your model wasn't hallucinating. It may have access to the context that was used to create your response. You may have access to the, you may want your evaluator to have some other steps, like perhaps you can implement fact checking, or maybe you have other skills that do some of fact checking. So if you have some type of, maybe imagine as an example, like you're getting some information from a document, which might not be the most recent information, you can hope to fact check that with another skill that does a Google search. So you can get the most real-time information. So yeah, as part of this overall framework, we want to have components that you can do that type of, I guess, prevention or trying to prevent hallucinations. But there's flexibility in how you do that.
Okay, thank you, Daniel.
It wouldn't completely remove it though, right? Like it reduces the likelihood, and then you can catch some more with post-processing still likely to happen.
That's correct, yeah.
All right, let's go on.
Awesome. Okay, and then I think this will be a bit of a repeat, but an evaluator is responsible for assessing the quality of the chains and the skills that are executed, and the controller determines the user intent, and then of course it routes it to one or multiple chains. The other thing that the controller does is, once those chains get executed, once they go through the evaluator, they go back to the controller, and it's the controller that determines the final response that's going to be, or responses, they're going to be sent back to the user. So now that I gave a more visual overview, I wanted to go through this very simple example quickly. It's a toy example that we have in a repo, but I want to showcase how this actually looks like when you patch this together in code. And so as a toy example here, we can instantiate an LLM model, which right now we're supporting an OpenAI LLM model that we load with some environment variables. And here we can define a skill. Now, I'll get a little bit more into more abstract skills, but out of the box right now, we have something called an LLM skill, which essentially connects to an LLM model. And so the input will be some type of prompt, and the output will be the result from the LLM. And then a chain will consist of one or more skills. So when you instantiate a chain, you give it a name, you give it a type of chain description, which can actually be very important, because one of the ways in which you might want to route a user message to an appropriate chain is by matching that based on the chain description, which is something that a language model can do really well. And then we provide a list of the skills for the chain, in which case here it's just that single skill. We instantiate a secondary chain in the same way. So these are, one is writing a poem, one is responding with emojis. But once we have our chains, the next thing we need to instantiate an agent as a controller. So we have something called an LLM controller out of the box in Council, and this uses a language model to figure out, based on the user message and based on the descriptions provided to the different chains, which chain should execute. And we have an evaluator as well that we need for an agent. And here, out of the box, we have something called an LLM evaluator, which uses, again, a language model to score the different responses from different chains. And then you might filter based on the highest score. So when you're actually defining an agent, these are the things you need to provide. You need to provide a controller, chains, and an evaluator. So that's what I wanted to kind of highlight at a high level.
This
Yeah.
sounds like a hacky mixture of experts kind of approach, where you determine which model to essentially send the request to, right?
Yeah. And when you're sending these requests, of course, it could be a model, it could be not a model. It really kind of depends on what type of functionality you want your agents to have overall.
Yeah, Daniel, could you talk a little more about how the evaluation would work? Like, is that something that you choose to build, or is there going to be predefined ways for evaluating things? In the code, it looks like not much is implemented there right now.
Yeah, so maybe it's a good time. I'll just jump into here. So an evaluator, if you look at just the base class, it's very obviously very minimal. Like there's an execute function, and what you're doing is you're taking in the context that the agent holds, everything up to that point. So the conversational history, the results of all the previous skills and chains, and you have to submit a list of some type of scores of the messages. So you look at the messages and you give them a score. In practice, like one example that we have is using a language model to do that ranking. So the important part here would be looking at the prompt that's being built. So here you have a grader that is looking at the responses and giving them a grade from 0 to 10, for example. And that's your output, which you can then parse and send back those score results to the evaluator.
Thanks, that's helpful.
Yeah, and that's probably we have another one, which is could be a useful starting point as well, where we're checking essentially for all of the chains that executed, were they executed successfully, and if so, let's pass them on to the controller to select the best response. So again, this could be a useful starting point for various things, but that's sort of what we have, for now, out of the box here.
I have questions about the state management.
Yep.
Okay, so this is just recording the history of the agent or the chains that's being used, or can I specify, let's say, I know a certain task or certain things that I need to do, and I know these are the states that has to go through. Can I predefine those states, and the controller will check the current state against the designed state? I don't know if you understand my question.
I think so. So what I would say is the agent context essentially. So I can answer that in sort of two ways. So first, the agent context, and then just state variables in general. So the agent context that gets passed along to every single what part. So this is what the controller and the evaluator has, and the agent context, it has the entire chat history. It has the entire chain history. So for all chains, what were the different results of the chain execution for each of the skills within the chain, that is. And then as well, what was the history from the evaluator? So that's something. So let's say if you are starting a skill and you want to get information in that skill for what was the last user message that was sent, then it's very easy to look at the context, the chain specific context that you can pull out of the agent context. That happens automatically, and refer to that sort of last message. In terms of having other state variables within the agent system, that's something that can be done with the controller. So the controller itself can do several things. When you are initializing a chain, you can actually initialize that chain with some initial state that gets passed along to that chain. as a variable that that chain can use. So if you think about maybe that chain has some type of function that needs, some type of argument, the controller can do that. If it's a type of chain that maybe you want the controller to reformulate the user message in some way. For example, you want it to be better used for some type of semantic search or another search system. The controller can also do that as part of its plan execution. So it's not just about selecting chains. You can make it more customizable, more advanced, to also come up with different state variables that can then be passed along to the chains. Or even if you kind of go further, once you iterate through the evaluator and you get the results back, the controller could then use those state variables to determine whether to continue planning and iterating, which is an example, hopefully I'll have some time to get to, that I want to show, I think, which will also answer your question a bit more.
Okay, that's perfect. Thank you.
Can I also ask one question while we are looking at the code? So one of the first things that caught my eye about your project is the word predictable. Because generally speaking, in our experience, and also a lot of people I've interacted with on social media complain about agent behaviors not being predictable. Yeah. Because if the LLM is, making the decisions and, decomposing tasks and all of those things, it could, a very, very common problem is that it falls into loops, or it determines, tasks, subtask skills that are not necessarily the best takes to action, etc. So when you say predictable, could you first define what you mean by predictable? And then also talk a bit about under the hood, how is that predictability being provided?
Sure. So predictability, I think, partly it comes down to how much control you have of the system based on the parameters you can set for it. So starting, I guess, from deciding what your agent can execute, you're the one who's providing the skills and the chains. So the agent, can only sort of stay within those decisions. So if you provide 3 chains, though, that's exactly the only type of execution that can happen. And you can have customizability. So let's say that, and by the way, what you're looking at here is the LLM controller from the quick demo that I showed that selects a plan based on the descriptions of the chains. Just it gets the categories from the name of the chain and the chain description, and then the instructions are to score them out of 10. And then you parse what are the chain names with the highest score, and then you execute them. So you can obviously select which chains can be, executed in the first place. You have a few other thresholds. So the response threshold, for example, was you only want, after sort of greater than minimum score to execute. If you only want to be able to choose to select only one chain every single time, you can set this parameter for the top K execution plan. So you can set it to only 1, only 2. So you have some sort of control there. Another problem that can happen is if you have some type of agent system that can do pretty much anything, and there isn't a concrete set of skills that you give it, you might also run into issues with on consumption budgets. So the time that it takes to give a result, the money that's being spent on the result as well. So when you actually execute an agent, I showed you the instantiation of an agent, but when you execute an agent, you have to provide another argument for a budget. So if you want your agent to not run longer for 2 minutes, for example, then you give a budget of 120 seconds. And so if you don't get a response by then the program will stop. Or if you have an agent that can iteratively refine on its answers, then it might just keep doing that, and it might keep refining, and you might be making more and more API calls, and cost more and more money. So again, a lot of times, generally, if you just use something out of the box, you might not have control there. But with Council, you can start to put limits on things like API calls as well. So you have more control over the latency and how many resources you're also consuming. And then finally, of course, the evaluator is meant to sort of help with that. So if you're not comfortable, you can make evaluators where you know they sort of act as this filter where you can hopefully be more comfortable with the result that you do get back.
Cool. Can I ask a follow-up question? So have you found any sort of way to benchmark how controllable, quote unquote, controllable the chains are? Like, is there a way to quantitatively, test and for various scenarios? And then an additional question to that is, what are the failure modes? Like, where do you usually see that this controllability falls apart in the current implementation?
Yeah, in terms of quantitative benchmarking, I'm not sure that I can answer that off the top of my head. Maybe in comparison to something like, I believe like there was an AutoGPT project, which people at least qualitatively complain about, like it just running in a loop and it doesn't stop. Whereas with Council, we want to at least protect against that. So you can do only a concrete set of things, and if you don't get a result after a certain amount of time, or if you used up a certain amount of API calls, then you just stop the program, you stop the execution. So if you recall, one of the chains that I was highlighting was an agent chain. So meaning an agent can delegate work to another agent. And then that agent itself will have its own chains and skills. That's something that we call an agent chain. And so this happens recursively. So again, an agent can be nested within another agent. And rather than having a single agent, you might have more complex applications that can function as a team of agents. And one highlighting example could be if you have, let's say, a topic on doing sort of a research analysis on a data set, then perhaps you might want to think about breaking that problem down with two agents. So you may have one agent that's the research agent and another agent that's the SQL agent. And each of them are going to have their own separate set of skills, where the research agent will be more focused on generating hypotheses about the data set that a user may want to generate, and summarize the results from the agent, and also delegate when you need to get data. It can delegate to the SQL agent, and the SQL agent will be more focused on dealing with and gathering data from your databases. So that segregating the responsibility of different agents and having them work together as one system. Just one thing that I wanted to cover before showing some more examples was more advanced usages of the controller. So beyond just simply selecting which chains to run and then selecting a response based off of those chains, you can try using controller in different ways. So one way that I think I already mentioned was having an initial state for a chain, so some type of argument or variable or dictionary variables, or really anything that a chain begins with that it can use for its execution. You can certainly ask a controller to do multiple tasks. So let's say you're using a powerful language model, maybe a GPT-4. So instead of just selecting the ranking your chains, you can ask it to do other things in the same prompt. Maybe you're looking at the conversational history and you're reformulating that query for some improved search results in some of the skills, or really anything else. Another thing is you can aggregate results from multiple chains in the controller. So when the evaluator sends back several different results, instead of just simply selecting one or more responses, you can have more complicated logic there by, let's say, taking different responses from maybe different chains and different sources, and then actually just having another language model aggregate that into a larger result. Then, of course, the planning iteration. So if the controller can then also look at the results back from the evaluator and determine, is this ready? So maybe you're writing a research report and you have certain criteria until which you continue planning and iterating if you're not ready, if the paper hasn't fulfilled those different criteria. So you can continue having that type of iteration as well. And of course, another thing, future good usage would be getting human feedback. So perhaps the controller can ask for feedback. It can ask for a clarifying question, etc. So of course, not an exhaustive list, but some motivating examples for starting to build more sophisticated agents. So I want to now maybe show a few more code snippets, but not from the Council code base itself, but from some examples that we've been working on to highlight different usages of the framework. The first one is essentially a financial analyst, which is interesting to me. If you know me well enough, I used to have a whole other career in finance beforehand. And so some of the things that I want to highlight here are the integrability with some other tools where Council can unify them in an agent, and also some more advanced usages of controller. So yes, I have this repo over here that you can check out. Now, I'm not going to go through in detail through every single notebook that I've created, but but if you're interested in creating an agent like that from scratch, then I have a tutorial overview with a set of notebooks that go through and create it from essentially in a linear fashion from scratch. But otherwise, this Council financial analyst agent essentially has access to chains with different data types. So here, I'm asking it, let's say, what is the financial performance of Microsoft? And I've given it access to Microsoft company financial documents. It has access to doing real-time search with Google Search and Google News. And I've also given it a data set of some historical Microsoft prices, stock prices. And so in a sample response, it could look and aggregate things from different sources. So, according to the 10K report, which is a financial report that public companies have to annually create, it then looks at the results from Google and then also does some analysis on the historical price data. So here we are sort of aggregating the results of the different chains. A bit more concretely, so one chain essentially is a document retrieval. So I've taken the 10K PDF, I've created a vector index using llama index, and which can be wrapped in a skill. And then you do some type of semantic similarity search based on the user query, and you can retrieve chunks of financial documents that are relevant. For doing the stock analysis, I'm relying on another open source project called Pandas AI, which makes Pandas data frames more conversational through the use of language models. And then as part of Council, we have a few skills out of the box on doing searching with Google. So what I'm doing here with my controller is I have two sort of tasks here, where the first task is it's not.
Could you zoom in? It's hard.
Absolutely. So my first task is taking a look at the conversational history, the query that the user submitted, and then updating it to improve the results of the search. So just to give an example of why this might be useful, if you asked, the first question was asking, who's the CEO of OpenAI, and you answer Sam Altman. But if you then follow up in a conversational manner, like how old is he? If you were to send how old is he to a skill using Google, you wouldn't really get relevant results. So I would want my controller to reformulate that so it's more useful for the search skills. So you reformulate it to how old is Sam Altman, which is obviously going to give you a lot more relevant results. But only reformulate it if you need to, of course. So here I'm giving it a few, couple of few shot examples within the prompt. And then the second part of the prompt is ranking the different chains to decide which one to execute. And just to give an example of initial state, so here the result from the updated query for the searching skills, I'm adding as an initial state to my chain, meaning now, like when I'm starting to run, let's say my Google search skill, I can refer to this information from the chain, and I can search that rather than purely the user question, which might not be optimal for Google searching. And then, so of course, this covers the first main function that a controller has, which is getting a plan, which gives you the list of your execution units. And that's essentially a list of chains that you're going to execute along with their initial states. And then the second main method that a controller has is a select response one. And what I'm doing here is I have another LLM call that takes all of the responses that I get from the previous chain. So that could be the response that I get from my financial documents. It could be the response that I get from my stock price analysis, plus my Google results. And then I aggregate that into a sort of report fashion. So that's the first sort of usage of more advanced control, and also integrating with a few different skills. The second example that I want to give is we've also created a research writing assistant tutorial, where here the focus is on being able to iteratively plan, write, and revise a research article. So the focus here is going to be more on planning with a controller. So we also have a repository here with, if you look into the docs folder, you're also going to see a list of notebooks that build up the agent in a sequential fashion. And if you're interested, I encourage you to go through. I will go and quickly give an overview of the controller again, where essentially at a high level here, maybe first I'll give some more motivating examples. So let's say that you're asked to write a research article about the history of box manufacturing. Very great topic, obviously. And you could obviously get a result from GPT-4, which if you try and ask it about boxes, certainly it knows something. But if you do this in this iterative fashion, you get a much more verbose result. And to give an overview, just let's go back to the controller. So essentially, we have we're going to have two chains and two skills here. One chain / skill. Each chain is going to have one skill. The first one is responsible for writing an overview of a research article, and the next one will be responsible for actually writing the article itself and filling in those overview, those outline sections. And so once, imagine you have your first iteration of the outline, you have your first iteration of the article. Do you continue to work on it? This is where a few things come in. So first of all, we have a few state variables, which is sort of a bit of a new topic to show. So within your controller itself, you can choose to manage, it can have its own state variables. So for every iteration, we're going to be counting, one. So the first time you take the first stab at the article, the first iteration, the second stab at the article will be the second iteration. And the other initial variables will be the article and the outline itself. So originally, they're going to start off, they're just going to be empty strings. But after every iteration, we're going to fill this, get these to be the latest version of the article. And then the controller can use these variables to decide whether to continue to write or not. So I think the meat of it that I want to show is really here. So after the first, or after an iteration of the article, we're going to provide instructions to a controller powered by language model to decide whether to keep editing or not keep editing, given a checklist. So we have a checklist here, checking whether it has empty sections, whether it's coherent or not. Is it, fewer than 3 paragraphs? Does it include everything that is being requested by the outline? Is it, long enough? So we can have our own checklist of criteria for which we provide, we can provide the outline, we can provide the article. And then essentially we ask it to either keep editing or to, return the final result. So if we keep editing, we don't return an empty list. Return an empty list, in which case the way that the agent is set up means it's going to continue iterating, or we return the article itself.